that, I will give a brief overview about this webinar. First of all, I welcome those who agreed to host the sensors, which you will learn a bit more in this webinar. So what I will present today is just give you an overview that why we need this project. So if you really see the air pollution monitoring system and scenario in India, we realize that we need a hybrid system. So if you look into this map here, which shows basically the location of the ground-based monitoring, and this circle here represents the Indo-Gangetic Basin. So the background color is actually the pollution level in India. And you can see from these numbers is that, the higher number indicates the air quality is very poor in this region. And you can clearly see that the entire Indo-Gangetic plain has very poor air quality. However, if you really look into the monitor distributions, you can see there is a cluster of monitors in Delhi NCR region and to some extent in the Haryana and Punjab. But there is a huge gap in the ground-based monitoring in this entire region. In fact, if you really look into the statistics, what we found today is that 45% of the districts in India do not have a single monitoring site. And there is absolutely no monitoring in the rural areas. All our existing ground-based monitors are in the urban centers. And that's why if you try to calculate what is the mean distance to a nearest monitor for the Indian population, that number is pretty large, 80 kilometers. And we did some estimate that if we really want to deploy an adequate number of reference grade monitors, we need at least $1 billion US, which is really a very high amount for India. So what is the way forward? The way forward, what I believe and many others also believe, that we should adopt a hybrid approach by integrating various alternate methods. So one alternate method which is gaining popularity today is the satellite data. Dr. Pawan will mention about this in more detail. I just want to mention that very recently Central Pollution Control Board started this project with us, where we are developing a national database of air pollution at very high resolution. So we are monitoring every 1 kilometer by 1 kilometer grid of India for the more than 20+ years. And we have calibrated and validated this with the Central Pollution Control Board measurement. And this website, which you can access from this link, it gives you all the details about this database, how it is generated, how good is the data, as well as you can access the data. I want to mention that when we tried to calibrate our satellite-based measurements, we found that especially in the area where we do not have monitoring, those gaps, they really impact your calibration. And that is why we really need to fill that spatial data gap. The other alternate way to monitor air pollution, and which is gaining very quick importance as of now, is the low-cost sensors. And that brings us for this webinar. If you really see a comparison between the regulatory monitors and low-cost sensors, typically a regulatory monitor costs around $15,000 to $100,000. Plus side is that obviously they provide very high quality measurements. Their performance is quite predictable. However, first of all, they are very costly. So you cannot really plan a dense network with this high cost, regulatory monitors. At the same time, they also need highly trained technical staff to maintain them. So in India, again, that's a very big question, because we do not have such kind of technical resource available with us. On the other side, if you look at the low-cost sensors, they are easily affordable. So, and typically they cost around $100 to $1,000. They're highly suited for dense network. Their maintenance is very simple, and that's what actually is what is more attracting about this low-cost sensors. And what our experience suggests that good accuracy is achievable if we do proper calibration of these low-cost sensors. And we will learn more about this particular sensor properly in this webinar. However, I must mention that these low-cost sensors need rigorous attention because their uncertainty is a little bit high, so they need periodic calibration. And so far, they have not really tested in the Indian conditions. Only recently we have started testing this various low-cost sensors in these Indian conditions. And by Indian conditions, I mean most of the low-cost sensors are tested in developed countries where the air pollution level is many-fold lower than the pollution level in India. So with this introduction, I hand it over to Dr. Prakash, who will update about this particular project which we are planning with the low-cost sensor. Over to you, Prakash.
Thank you, Sagnik. Good evening, everyone. I'm glad to have all of you participate in this webinar. So let me go ahead and share my slides here. Can you see my slides?
Not seeing them just yet, Prakash.
Okay. All right. How about now?
Yes, we have them.
Yeah, now.
Okay, good. Okay, still seeing it in slideshow mode?
We're in presenter mode, so if you want to go up to display settings, I think you can move it too.
Sorry, how do I do that?
If you go back to the presentation mode you were in.
Okay.
Okay, then up on the left display.
Yeah.
And there's do
swap.
Duplicate slideshow.
I see, got it. Okay. Can you see it now?
Yeah, perfect.
Okay, wonderful. All right, so yeah, again, welcome everyone. So good evening to all of you. So like Dr. Sagnik provided a good introduction to this webinar as such. Here's a quick overview of the agenda for today. So I'll give a project overview. Followed by that, we will have Dr. Brandon Fienstra of South Coast Air Quality Management District, who will talk about the purple air sensor that is going to be used on this project, how to register it, install it, as well as how to access the data. Then after that, Dr. Pawan Gupta from USRA NASA will present a little bit about the satellite side of the project, and depending on time, give a quick demo of the Worldview website. Following that, we'll have Ms. Kurunji and Ms. Tanushri from CEW talk about their experience in how these low-cost sensors can be useful. It's a different low-cost sensor, but the application, the lessons learned are portable. And finally, we will have Ms. Carmen talk about how you can be involved and the ways to be involved in this project. And finally, we'll end with the Q&A session. So just right, we have a couple of questions for you. So there, a poll should show up. So if you could please go ahead and fill this out. So this is how do you check your air quality in your neighborhood and how frequently do you check air quality in your region? That will help. At least it kind of gives us some idea of the background, gives us a perspective. And we will look at the results at the end when Ms. Carmen presents about the citizen-scientist interaction. All right, so talking about this project as such, so again, I'm a principal air quality scientist at RTI, and it's a nonprofit research institute. We are based in the US. We also have an office in Delhi. Sagnik already mentioned about the impact of air pollution. So this is a figure from a paper by Landrigan et al., which talks about the amount of pre-mortality attributed to air pollution. It's about 6.5 million annually. And when we look at where the deaths are focused, it's mostly in the low and middle income countries. These maps are from the website State of Global Air. And on the top left, it shows the absolute projected number of deaths, estimated number of deaths attributable to fine particles, that's PM 2.5. And on the bottom right is the standardized, the normalized to the population. So in both cases, you can see that the low and middle income countries have a larger proportion of these deaths. And so Sagnik presented briefly about the monitoring and the scarcity of the air quality monitors in India. So in order to manage air quality, monitoring is an important component, and there are multiple methods. The reference method that is expensive, as Sagnik mentioned, the satellite data that's in the middle, but then there's also this low-cost sensors. So the objective here is to see how these low-cost sensors, through the use of citizen scientists, through engaging citizen scientists, how can we use that approach to generate spatially and temporally resolved data that's also of good quality. And the idea here for the overall project is the satellites offer global coverage, but it is a column metric. In other words, it's looking at the whole atmospheric column, and the sensor data, the measurements, point measurements on the ground are being used to calibrate it, like Sagnik mentioned. So the idea is to be able to develop a more improved satellite product using the data from these low-cost sensors. This project has been in existence since about 2017. So we started out small as a feasibility phase, that's a prototype phase, to see if such a low-cost sensor network would be feasible. And we tried that in Los Angeles, California. And in phase 2, which is what we are currently in, we are expanding the network in Los Angeles, California, in Raleigh, North Carolina, as well as in Delhi. And the idea behind that is to have regions with different concentration ranges. Delhi representing region of high air pollution, high particle loading. Los Angeles, it's high for US standards, but probably on the median level globally. And then the Raleigh region to kind of represent a clean condition. And the idea behind that is because the calibration may vary depending on the concentration ranges, the sensor performance may vary depending on concentration ranges. And so we are doing this deployment in all 3 regions. And as you know, we are now expanding this deployment to Delhi. And we have collaborators from IIT and CEW who are helping us out. And so the focus is to collect continuous reliable data in a sustainable manner. And all of you are a critical part of this project as citizen scientists. So you will work with the team to collect these data. Just a current status, we have sensors already deployed in California, and it's ongoing in North Carolina and expanding. Sensors were evaluated against these reference methods at both of these locations. Sagnik also mentioned about an effort in India. So this kind of shows the sensors that you will be hosting. Each one of them was evaluated, was compared against the reference method. So that's shown on the figure there on the left. So all of the popular sensors and the reference method is at the far left. And the correlation, it shows really excellent correlation. And obviously, so we have this parameter for each of these sensors, and we'll be developing correction metrics for those. And the plan is to deploy around 100 sensors in India, spreading across the region indicated by Sagnik. So how can you help as a citizen scientist? Carmen will be going over a little bit more at the very end of this webinar, but primarily at a high level, you will help us host and maintain a sensor. We would like you to be involved as much as possible, kind of looking at the sensor data and satellite data. If there are questions of your own interest that you would like to explore, that'd be helpful, and probably collaborate with, engage with citizen scientists across the world. So we have obviously India and 2 regions within the US. And so that you can have kind of a global perspective and each of you can share information. Keep us informed of your sensor performance once you start monitoring it on a continuous basis. Is a sensor measuring unrealistically high value? How does it compare to nearby values? That will help us inform us if the sensor performance is degrading or if something else is interfering with the sensor. Once you have deployed the sensor, then we will send you information for requesting metadata. And what is metadata? It's additional information about the data itself. So that will help us correct the data from these sensors. For example, where is the sensor located? Was there a fire in your neighborhood? Is it, at what floor is the sensor? What height is the sensor installed? And so those kinds of questions, we will be distributing a survey for you to fill out, and that will come out later. If possible, please also send pictures of your sensors after deployment so that we can have at least an idea of the region nearby. And so that completes my presentation, and we will take questions at the end. So please go ahead and add your questions to the chat window. And I will turn over, and for more information, you can look at our project website. The website is being updated to include additional information, but this has all the basic information that's needed. Right, thank you. And I think I'll turn it over to Brandon now to talk about the sensor registration, installation, and the data access. Brandon, on to you.
All right, good evening to those in India. It's good morning here, so in the West Coast in the United States. I'm going to review and go over the purple air sensor, which is a sensor that we're using in this project. And going to kind of look at the Purple Air website where you can look and see the data from the air quality sensors that are used. So I'm an air quality specialist at South Coast Air Quality Management District. It's the air quality regulatory agency for Southern California in the United States. And I work in part of the Air Quality Sensor Performance Evaluation Center there. It's a program that evaluates the performance of sensors over time and provides all that information to the public. So a quick outline, we're first going to look at some siting considerations for installing the sensors. Then we're going to look at how we configure the Wi-Fi to get that sensor connected to the internet through your Wi-Fi at your home. And then we're going to look at the registration process, which is online. And finally, we'll look at the Purple Air web map. So in contrast to some of the pictures that you saw earlier, the Purple Air sensor is very small. It's about 2.5 inches by 5 inches. And it's very different than some of the larger air monitoring stations, which are used for regulatory purposes. So when you get the sensor, you're going to have the Purple Air sensor, outdoor power supply, and then some mounting hardware like a screw or zip ties in order to allow you to install that sensor somewhere at your home. The device measures particulate matter, so that's dust in the air, and it measures 3 different sizes of particulate matter. PM10, which is larger dust, which is more mechanically suspended by walking or by vehicles moving. PM2.5, which is smaller dust, and then very small dust, PM1. The device also measures pressure, temperature, and humidity. In order to get the sensor installed, configured to your Wi-Fi and registered, the 2 main requirements is power. So it does need to be connected to a power source, and it does need to have access to Wi-Fi. The estimated cost for this is around $230. That's taken care of by the project team here. But that cost there is kind of in contrast to the cost earlier that was provided in the hundred thousands for developing an air monitoring station and putting in those regulatory stations. So this is a more cost-effective means for getting air quality measurements into the communities and neighborhoods that may be impacted by poor air quality. Here's some of the highlights of the AQ spec, the Air Quality Sensor Performance Evaluation Center results for this sensor. This is the summary report, and it can be found at aqmd.gov/AQ spec. Prakash has already kind of gone into the details here. The sensor does correlate well to higher cost reference instrumentation. It does have slope and intercept offsets when compared in the Southern California region. And that's one of the reasons why in this project, a calibration was performed on these devices to correct for that. And all that information is public at the AQSpec website. So I'm not going to go into detail on this slide, but you can find this publicly available online. So getting into, once you guys receive your sensor, how do we get that sensor online? It's a 3-step process. First need to install it, Wi-Fi configure that sensor, and then register. And the order of these steps is a little bit arbitrary for the first 2. It is recommended that you perform the Wi-Fi configuration first. Plug that device in close to your Wi-Fi router where you have a very strong signal, and do that Wi-Fi configuration in your home before you actually install it outdoors. With regards to siting, we look for a location that is a good spot for taking an air quality measurement. This sensor here is installed on a deck, and there's wrought iron fence on the top of that deck, and it's zip tied to that fence. And so it has a good accessible, 180 degrees looking out. Here's another example where it's mounted on an eave of a home. And there's the sensor right there. And then here's a bad example of it mounted on a rooftop right next to an air conditioner unit, and it's zip tied there, and that sensor is about 1 inch from the floor there, so it's not getting a representative air quality measurement there. And so if you looked at the first 2 examples, those are getting a more representative air quality measurement, whereas this one is going to be impacted potentially from that vent in the background here, and then also from the heat of the air conditioner unit. So you want to find a good siting spot. Other considerations is you need to find a location where you can manage the cord in a way that it's not a tripping hazard, and also where install it. You can kind of see here we have an example of a drip loop where you want this to come down, and so any water would then not go up into the sensor, but it would drip off of that sensor. Similar here, keep that drip loop. There's guidelines that are on the Purple Air website that's available at www.purpleair.com, and that will give you a setup guide for installing this air quality sensor. There's some frequently asked questions there that can be very helpful, and as well the guide for setting it up. And they have some other pointers and help tidbits there. So one of the challenging parts is the Wi-Fi configuration, and we're going to go through this kind of step by step. So initially you're going to plug that sensor in. Once that sensor is plugged in, you should be seeing a red glow here, and that's indicating that you have successfully gotten power into the sensor. And at that point, you can go to a Wi-Fi enabled device, whether it's a cell phone or a tablet or even a computer, but something that can receive Wi-Fi. And you're going to click on the Wi-Fi settings. And then from there, you're going to look for a Wi-Fi network. So the sensor is going to broadcast its own Wi-Fi network. That network is going to be called Purple Air, and then dash, and then last 3 digits. And those will be the last 3 to 4 digits of the MAC address of the actual device. When you see that, click on that Wi-Fi and click to connect. And at that point, you're going to, this is looking at like a cell phone. So if you're using a tablet or a laptop, when you hit connect to that Wi-Fi, a browser may automatically open. If not, and if you're using a cell phone, you're going to need to open a browser and then type in the 192.168.4.1 into the internet browser. And if you do look at your Wi-Fi settings, it's going to tell you that the internet may not be available. But just know that once you're connected to it, it's because that device is actually not connected to the internet. It's just broadcasting a Wi-Fi, so you can connect to that device and configure it. And you don't need to worry about taking down these notes. We will be sending out an installation guide as well, along with the sensors, so that you'll be able to have all this information once you receive your sensors to help you get that device connected. So once you go to that website, the 192.168.4.1, you're going to see a screen like this. This is going to give you your current air quality readings from the two sensors. And you can look at the live readings, some averages. We're going to want to click on the Wi-Fi settings right here. Once you click on that, it's going to push you into a new screen here. It's going to tell you on the top that your Wi-Fi is not configured yet. And then you're going to select your Wi-Fi. So you would click on the box here, which is going to be your Wi-Fi from your home that's broadcasting from your router. Then you're going to put your password in at the bottom, which is going to, sometimes that's right on the router, or it's a custom password. And then click Save. And at that point, you have now configured that sensor to your home Wi-Fi. And that sensor should be connected to the internet and transmitting data. Now that that device is connected to the internet, the device needs to be registered with purpleair.com/register. And that's going to ask you for some information. And the first thing it's going to be looking for is the device ID or MAC address. That information is printed on the front of the device just above the barcode. And once you input that, you need to put in an associated email address. This is an email address that's associated with the purchase of the device. So that's going to be our project email address. It's going to be airqualitycs@rti.org. Then you're going to choose that this device is installed outside, and then the location name. So we're using a naming for all of our sensors. They're all already named, so you don't need to come up with your own custom name. The name is going to be NASA_AQCS_, and then the 3 question marks has to do with 3 numbers. So every one of the sensors has 3 numbers at the end of that, and yours will be right on the front of the sensor. You'll find that location name. For visibility, we're going to put public to everyone so that it's publicly available on the air quality map. And then for location, you can drag and drop this map to your location. If you know your latitude and longitude, you can put those in, or you can find those on Google Maps as well. With that, you're going to leave the data processors just the way it is, so it also sends data to Weather Underground. And then with regards to device owner's name, that's where you put in your first and last name, put in your email address, and then put in a phone number if you would like for text alerts. After that, click I agree with the terms and conditions, read those if you like, and then click register. And at this point, your device should be connected to your internet router, your Wi-Fi, and then it should also be registered, and the device should be then displaying data on a real-time air quality map. And this is the map here. Go ahead and we'll exit presenter mode, and we're going to go to the PurpleAir map. So this is the PurpleAir map. This is specifically for Southern California, the United States. And so this is interactive. We can zoom in, can zoom out. And currently this sensor is displaying AQI. You can change that parameter here. You can display humidity, temperature. You can even display the PM 2.5 in micrograms per cubic meter. That would be the value that we're most interested as air quality researchers. And so now it's displaying that value. You can change what type of averages you wanted to show. If you wanted to do 1 hour averages, you can change that to look at what the hourly readings are. And we can go back to the 10 minutes or even show real time. So depending on whether you want to know exactly what the conditions are now or what they are on an average. This gives you an indication of the values for air quality index. And now if you do find your sensor, just a real quick note, this button here is find your location. So you can click that and that'll bring you right to your location. So if you installed your sensor and you wanted to know what your sensor looks like, you can click that. And additionally, you're going to be receiving an email once you register the device. That'll give you a click link that you can choose to go directly to your device and get the data. If you were to click on a device, this one's in West Hollywood, and click on that, it's going to open up a screen. And so we can see what the last 10-minute average readings are, and then some of the different averages over time. So the week average is going to tell us whether this sensor A and B are agreeing, and gives us a little bit more information about the sensor. It's also going to plot this time series here for the last 2 weeks. This is an interactive plot, so we can zoom in if we want to zoom in on a certain period. And if we're interested in how this sensor is reading in comparison to a nearby sensor, we can also click on that one. And it'll also plot, now you have all 4 of those sensors in that time series. And we can see that during this period, there was a difference between the sensor 4041 and the other sensor that was nearby. So there was something in that region that caused these 2 spikes to happen, which is interesting to look at, especially the differences between sensors. With that, we can show you, just say you wanted to download these sensors, the sensor data, and get the actual raw data files. This button right here in the far right-hand side, if you can see where my mouse is, you can click that. It's going to bring you to the sensor download tool. And here we can then download those sensors that we're seeing in the map. You can click if you want both the A and the B sensor, and just click on those download buttons, or plug in your start date, your end date, if you would like an average, and then hit download selected. And that's going to give you a CSV of the data that you're looking for. You can download that. You can see it very quickly downloads the data for you. So this is a great tool to view your data, to access your data if you want to view it, access it. There are some other tools if you have programming skills that you can use, and you can read up about those on the PurpleAir website. I'll quickly just kind of run through. This is the install guides. So if you're looking for more information on the installation. And just one thing to note is that the device is designed to connect to your Wi-Fi, and this can do Wi-Fis that have a username and a password, but it does not work for locations that have a secondary authorization. For example, some universities or school districts will have an open Wi-Fi, but you have to then go to an internet browser and then input your student ID and password. This device does not have that capability at this time, so you'd have to somehow work with the information technology department and try and whitelist that MAC address for that open Wi-Fi, and start those conversations with the IT professionals and see if you can get that worked out. If you are trying to connect a device at a university, there may be some additional challenges. So that's what I wanted to show today, and be happy to answer any questions at the end of the webinar today.
Thank you, Brandon. Pawan?
Thank you, Prakash and Brandon. So I think both Sagnik and Prakash kind of have given some of the objective of the project, and there are 2 main objectives. One is we want to actually use the low-cost sensors to collect the air quality data from the ground, and then we use that data to learn how we can best integrate the satellite data with the ground measurement. So what I'm going to do, since this is our first interaction, so I would like to actually share a very easy to use satellite data tool which you can actually which is free and available to everyone, and I won't just go through it very quickly so that you have access to see satellite imageries on a daily basis And if you see some specific event when you deploy your sensor and want to see what's going on with the satellite data, whether satellite is capturing that specific air quality event or not, you will be able to see that. And as we move along the project in subsequent webinars or town hall meeting, which we'll organize in coming months, we will learn a little bit more in depth about the satellite data. So with that, let me share my screen, and I'm going to just quickly show you a tool which has been very, very popular and people use it all the time to access the satellite imageries. So let's see if I can share my windows. Okay, can you see my screen?
Yes, we can see your screen.
Okay, great. So just so that you don't have to remember the name, I'm just opening the Google and I will type NASA Worldview. The tool name is called Worldview. I'll just type that in a Google, and the first link you will see is USDIS Worldview, and that is the tool which we are going to use to access the real-time satellite data. And as you open this tool first time, it will actually give you a nice tutorial to explain what different data sets it has, how you can use it. So I will let you go through this in your own time. It's about 5 to 10 minute tutorial which really explain nicely how to use these tools. But very quickly, as soon as you open this, you will see today's image taken by the satellite all around the world. And there are not only one satellite, but there are many, many different satellites. So this specific tool is designed to provide you near real-time data from the satellite. When I say near real-time, it means as satellite is overpassing over certain location, the data should be available here in this tool within few hours of satellite overpass. And it's not only for air quality. You can get the data related to rainfall, weathers, cyclone, dust storm, fires, all kind of possible scenarios which are happening on the planet Earth can be actually seen from this tool. So very quickly on the bottom, you can change the date. It allows all the way to go to 2000 actually. You can change any years. You can change the month, date. You can also go by clicking this arrows going back and forth. So that is your time slider to choose the date. You can just double click on the map and it will zoom in. So this is today's map or today's satellite imageries over India. As we know, the monsoon season is going on over India. So you will see that a lot of these white colored things which you are seeing over India are basically clouds. You can see the water. These black areas are basically gaps in the satellite data. On the left side, what you see is a panel where you can actually select different data sets, or we call them layers. And there are two different layers here. One is the base layer. Base layer is basically these true color imageries where you can see things as you will see using your naked eye from the sky, right? So the white clouds appears white, land surface appears brown or gray, or depending on how much vegetation covers is there, and then the water appears dark. You can zoom in any specific area. These data are very high resolution. So if you actually zoom over northern India, you will see some hazy sky, and then rest of the India is actually covered with the cloud. You can change this satellite. There is this particular satellite makes measurement in the morning called Modus Terra, and then you can change to the afternoon. This is an afternoon satellite. There are other satellites also called VIIRS, which actually does not have those gaps. So you can actually change around, look around this and free. On the type right part, there are other options. You can share what you see on your screen using a link. If you copy paste this link and send to somebody or post on social media, they will see exactly what you're seeing here. You can take pictures like snapshots of any area. You can also animate for certain days. So it will take a minute, but you can see several days how things are moving around from the different satellite. Just very quickly, you can turn on and off some of the overlays like place names or coastlines and the borders so that you can identify areas where you are. So this is Delhi, today's image. You can zoom in further to see more and more options here. Now, I will just quickly show a parameter which we often use. There are two actually. One is called fire. So when you click on the aid layers, you will see a window appearing with the different thematic areas. So air quality, ash, fire, dust storm, drought, flood. So you see this is a long list. This specific tools holds more than 500 different parameters. The one which are relevant to the air quality are listed here. I'm going to just show you the fire and thermal anomalies. Again, when you click on that, on the right side, you will see a lot of information if you want to read about the specific parameter. And then here on the left, you can choose which satellite you want to explore. So Sumi NPP viewers is one of the satellite. Again, I'm going a little bit fast here, but if you are interested, we will be happy to provide a lot more information on these specific sensors. So once you click that, the fire locations should start appearing. So as we can see over India, there's not much going on in terms of the fires, but there are other parts of the world where there's a lot of fires are burning, right? For example, in the Southern Africa, if you go one day back, then you can see actually other parts of the world where there's the fires happening. You can see this is a fire season in Amazon forest. We see that often in the news. There are a lot of fires going on in Siberia, in Australia, and other parts of the world. So these basically gives you the locations of the fires. You can see twice a day. Um, there are other parameters also, but I think we are running out of time, so I'll just stop here, and we'll be happy to take question at the end. And like I said, we will go through these things a little bit in more details as the project progress in subsequent webinar and town hall meetings. Thanks, everyone. Um, that's all I have, and I think next is Kuranji.
Thank you, Pawan. Tanushree, if you could share the screen. Thank you very much for staying with us. My name is Kuranji. I'm a researcher at the Council on Energy, Environment and Water. Today, I will be talking about how LOCA sensors helped us to study crop residue burning, a major seasonal crisis that impacts air quality. Next slide. The Council is one of South Asia's leading not-for-profit policy research institutions. We work across 7 focus areas and we have 1 Center for Energy Finance. Next slide, please. Let's have a little background of crop residue burning. We took this picture during our field visit in Punjab. Here in the picture, you can see the standing paddy crop at one side. Lack of crop diversification coupled with market structures and food procurement policy has resulted in intensive paddy cultivation in the state. Being a water-intensive crop, this has distorted the groundwater table. Now look at the other side. You can see the paddy harvested land. After harvesting, given the short turnaround window of 10 to 15 days to clear the fields, farmers are burning the residue. The resultant smoke and emissions are polluting the air, which you can see in this picture as well. This is how agriculture, water, and air gets linked with each other. Next slide. And this is happening over several decades now. To understand how the crop residue burning has changed over the years, using NASA satellite data, we estimated the fire counts for Punjab. Graph here gives the fire counts recorded during paddy residue burning season. By and large, the counts remain reasonably steady. Next slide. This table from the Global Burden of Disease report gives the contributors of air pollution in India. Other than coal, biomass burning and open burning, which could be either crop residue or other waste, are leading contributors. These two are more prominent in rural areas. The exposure levels are even high, but air quality stations in India are mostly concentrated in urban areas. Also, often crop residue burning is discussed in the context of Delhi's air pollution, but we were very interested in tracking how this practice affects the local air quality. When we looked at the Pollution Control Board portal, we found that Punjab has just 8 continuous stations for the entire state, and all of them are in urban areas. Just to give you a sense, Delhi has 38 monitoring stations, nearly 5 times that of Punjab. Next slide. Sensing this data gap, we deployed 48 locus sensors in rural Punjab across 4 districts: Sangrur, Ludhiana, Pathankot, Hoshiarpur in October 2018. We selected these districts based on number of fire counts. Sangrur and Ludhiana are high burn and Pathankot and Hoshiarpur are low burn districts. The picture in the side is taken during the installation process. We made sure that the device has 24-hour power supply and placed close to the field, and there is no other sources such as diesel pumps close to the device. Next slide. Here we can see the PM 2.5 average measured across the 4 districts during paddy burning season in 2018. As you can see from the figure, during peak burning season, PM 2.5 levels are crossing more than the national air quality standards, which is 60 microgram per meter cube. More so in Sangrur and Ludhiana, which are shown in gray and orange lines respectively. These are high paddy cultivated areas. The blue and green lines represent PM 2.5 levels of Hoshiarpur and Pathankot, which are low burn districts. They demonstrated better air quality. Clearly, burning has a huge impact on local air quality. Next slide, please. Now let's just focus on Sangrur, one of the high burn districts of Punjab. The black line gives the daily fire counts observed in that state. The white box plots gives the PM 2.5 values. What we observed is the good correlation between PM levels and the fire counts. During peak burning season, Delhi experiences severe and emergency situations. Similarly, Punjab also sees huge spikes in their air quality, but the impact on local population is not well understood or communicated. Use of local sensors illustrates the gravity of the situation and helps us to keep a watch on such pollution events. Next slide, please. In addition, satellites are instrumental in tracking the progress over years. Here you can see the district level fire counts observed in 2012 and 2018. If you can clearly observe, districts such as Muktsar, Firozpur and Bathinda have worsened over the course of time. No improvement was observed in Sangrur. So there are several policy measures in place by state and central government to curb this practice, such as announcing fines and bans on crop residue burning and subsidy for crop residue managing machineries. However, tracking these data comes handy to strategically plan targeted interventions to those regions like Sangrur or Muktsar that need much attention. Though satellite data gives a wider picture on fire counts, they are not real time. The fire counts data that in this case will be made available after 3 hours. Also, since these are not geostationary satellites, we get information only whenever the satellite overpasses the region, that is 2 observations in a day. This is where locus sensors complement satellite data by giving you real-time information. More real time you get the data, more promptly you can clamp down the activity that is causing the spike. This is all from my end. Thank you so much for this opportunity.
Thank you, Kurunji. I think now we'll go to Carmen.
Hi, everyone. Thank you, Prakash.
Carmen, your volume is a little bit on the low end.
Oh, thank you for letting me know that. Is that better, Prakash?
Yes.
Thank you.
Thank you.
That happens sometimes. Okay, so I wanted to take a few minutes to talk about how citizen scientists and the project team here online is and will be interacting, and the opportunities that you all have, not just to get a sensor to monitor your own air quality, but to also be a part of a worldwide network of citizen scientists. So why is RTI engaged in this project? Well, our institute is an independent nonprofit research organization based in the US, but with offices across the world. We are dedicated to improving the human condition. All of our research is focused on efforts to improve the human condition. And we have efforts across the social and laboratory sciences, engineering, and international development. Our goal is to deliver solutions to the critical needs of our clients, whether that's basic research up to larger studies, commercialization efforts to help technologies come to fruition that improve our lives. I am participating in this project as a project manager, but also helping with the citizen science interactions, recruiting, and all of that side of the project. Prakash Doraiswamy is our principal investigator and lead scientist on this effort. So as a community of citizen scientists and scientists, we have a wealth of opportunities for data gathering and data assessment. Part of what our project team wants to do is share outward what we are finding and seeing across the data sets and the scientific community. So we are currently sending out regular email newsletters to our list of interested participants, and also posting blog updates to our website. Blog updates, though, our blog is a mix of project team activities and citizen scientist activities. So I'll get back to that more in a second. And then also we've started up what we call town hall meetings. And the town halls are really meant for not just the project team to share what we're doing, but more so for the community of citizen scientists to have a platform where they can share what they're finding and building and discovering. So to date, we've used these town hall sessions to share current events in air quality, whether usually it's related to weather events, but sometimes things like fires that are occurring, and also share tools that we are building, that citizen scientists are building, as well as data or data sets that have been found interesting, and then also to share ideas on what investigations could be done with the data sets, ideas of what things could be studied. At any time, the project team and citizen scientists are invited to share thoughts on our Slack channel. So there is a URL here on the slide for the Slack channel. We are going to send out slides after this, so don't worry about writing this down because you will have it. You will also have it later. On our project website, we offer a page where you can view the sensors on a map that have been distributed through this project. At this moment, we share the map for Los Angeles. We need specific sensor ID information. So as we expand, as we've expanded deployment of the sensors from Los Angeles to then Raleigh, North Carolina, we are gathering the right data to connect our sensors real time to our project website. So we will expand this map, this page, to include the Raleigh, North Carolina deployment next. And then as you all receive sensors and start deploying, then we'll be able to expand the map to Delhi as well. This is our project website's view of sensors. Of course, they can always, as soon as they're registered, be viewable on the Purple Air website, purpleair.com. But at our website, you can get to the map at the top at the tab called View Air Quality Data. Okay, so I shared how the project team is giving information out on a regular basis. This is more on how you as a community of citizen scientists can participate. So from our website, you are able to get to the Slack channel. You're always welcome to send us blogs that would be a write-up of your experiences or your findings. I've put in the bottom right on this slide a screenshot of our most recent blog post from a citizen scientist in Raleigh. And then before you are receiving a sensor, we would like for you to fill out a participant questionnaire, which I have a link to that on the next slide. And then in social media, there's a few options, first of which would be Twitter, following not just our project team, which these are the handles for some of our project team that are active on Twitter, but also relevant organizations related to citizen science, not just air quality, but SciStarter is a really good resource for all kinds of citizen science projects. Also NASA Earth, NASA Goddard, sharing a lot of their findings via Twitter, and then South Coast AQMD is sharing information related to California air quality. And on Facebook, a really good place to start as soon as you're receiving your sensors, if you're on Facebook, is to join the Purple Air Users Group. And that's a group run by the company who makes the Purple Air sensor. It's a good community of people from the manufacturer and people who have purchased the devices and have installed their own Purple Air devices. So it's not just people from our project, but it's all users of this brand of sensor, which I think is a great branch off community to be a part of as well. There is another Facebook group for air quality in northern India, which I will send out more information on that in a future communication, but that is potentially another opportunity of place to interact. If you have ideas also of other communities focused on air quality, other groups online, I think it would be really great to not just keep participating there, but also to share that with your fellow citizen scientists, and you're always welcome to share that. I think the Slack channel would be a really good place to share ideas of what other communities to get involved with. Okay, so like I mentioned in the last slide, before receiving your sensor, you would need to fill out the participant questionnaire. You can go to our project website, aqcitizenscience.rti.org, and on the bottom right, there will be a link to say, sign up to host a sensor in Delhi, India. You can go the traditional route and go to the website to fill out there, or you can get your phone out right now and go to your camera and focus your camera over this QR code in the bottom left, and you can go ahead and fill out the questionnaire that way too. This QR code will take you to our project website. I'll give a couple seconds for everyone who would like to do that to go ahead and try. Okay. If you didn't get to do it in those few seconds, no worries. The slide will be coming to you and more information will be coming in email. So you didn't miss out. So this is a thank you slide, but I think we're going to take a few minutes to go through some questions that came through email and chat during the presentations. Prakash, you and I are going to be moderating this portion. And here are a few of the questions that came in earlier during the webinar. So we will start with, when and how will sensors be distributed to attendees of the webinar?
Yeah, so Sagnik, do you want to take that?
Mm-hmm.
Yeah, sure, Prakash. Okay, so so the sensors are with us. So I think we are planning to distribute the sensors in the next 2 weeks. So we will contact you personally before scheduling a visit. So our team will go and deliver it personally to most of you.
Okay, thank you, Sagnik.
Yeah.
I think there was also another question on the chat related to this, is whether you should order the device or whether we will provide it. So the project will provide free of cost one purple air sensor for each citizen scientist, depending on the location that you are based at. And the reason for that is we obviously would like to have a good spread to capture the spatial gradients. So depending on how many people are located right next to each other, then we may not be able to give sensors to every one of you. But I think most of you on this webinar have been invited personally to be part of this project. So we'll be able to share more information on that. But we'll be providing one sensor free of cost. And again, this is for outdoor monitoring, not for indoor air quality. Just want to be clear on that aspect as well. Okay, the next two questions are related to the role of citizen scientists with regards to the ongoing COVID pandemic. I think that's obviously we are in a different situation right now, and in terms of this project, I think this question is a little bit broad, and in terms of, like, obviously each citizen has a role of their own, but in terms of this specific project, like Sagnik said, we will be delivering the sensors. And I think in terms of the sensors themselves, they will be able to monitor the air quality impact. At least we have seen that they've been able to capture the changes in air quality related to COVID-19. Well, as a result of a lockdown imposed by COVID-19 and other interfering factors. So I think that's all I can think of. Does anyone else from the presenters want to add anything more?
No, so this is Pawan. I just want to add that during the COVID, I think it is important to stay safe. So if you feel
Right,
that
yes.
during the process of installation or during the interaction with anybody individually, locally, you need to, we will prefer you avoid those. So just stay safe, take your precautions while you're helping us collect the quality data.
Thank you, Pawan. That was most relevant. All right. Apart from lockdown and social distance implementation, is there any significant influence of indoor pollution on COVID-19 spread? Again, that's I think it's an area of ongoing research. What's been found, so this is not related to this project as such, but what's been, at least in the latest literature and news, what's been found is that the ventilation helps. So the larger the air ventilation, it helps reduce the aerosol burden and ultimately the impact of the spread of the virus. Does anyone else want to add anything more to that? Okay. The next question is, what is the way forward planned to connect the India citizen scientists to global scientists? Any exchange programs and or funding opportunities? That's an excellent question. I think as we mentioned during the webinar here, obviously we have a group of citizen scientists from 2 locations within the US. As part of these, the Slack channel, the town halls and the newsletters, we hope to engage in citizens from across these different regions. So please feel free to share data, findings, or any questions that you might have to kind of initiate these conversations between the citizen scientists. We do hope to have a workshop, a final workshop sometime during, it was initially planned for next year, but with COVID, it's still up in the air. But we do hope to have one final workshop that will also bring together some of the citizen scientists from all the different regions. Any exchange programs under funding opportunities, there are probably funding opportunities outside this specific project. I don't have those details with me at the moment, but obviously this project does not provide funding as such for any of these exchange programs. I know the Department of State has some such exchange programs that you might be able to check out to see if that might be relevant.
Okay, thanks, Prakash. And then we have one more question in the Q&A. What are the basic requirements, if any, for becoming a citizen scientist? Okay, well, the first thing is to be interested, be curious. But for this project, the initial requirement would be to fill out our participant questionnaire and help us understand what latitude and longitude you would like, at which latitude and longitude you would like to install a sensor. We are trying to get a robust distribution geographically, so we don't want to accidentally cluster too many sensors together from the project. So that would be the second thing. And then the third thing would be that you need to already have identified a location that has fairly good Wi-Fi and electricity connection, because the sensor is very easy to install, but you have to have constant reliable electricity and Wi-Fi. Any other requirements, Prakash?
I think you covered most of it. Yeah, and yeah, just engage with other citizen scientists. I think that's mainly it.
Okay.
So I did have no more questions online.
So there is a, Prakash, this is Pawan. There's another comment or question here in the chat box. I think it is related how long the project will go and what is expected in terms of how long they want to run the sensor, I believe.
Okay, got it. Yeah, so the project, as of now, the project is supposed to go until July of next year, 2021. And given the ongoing COVID pandemic, we anticipate or we hope to request additional time frame to complete the deployment and the data analysis. But as far as the sensor is concerned, we are distributing it to you free of cost for you to keep, and keep it active so that the sensor will continue collecting data as long as it's working. And we do hope to keep the website alive at least for a while after the project is over, depending on the data and everything and other factors. But yeah, the sensor is for yours to keep to contribute data to this project.
Yeah, what I just want to add one more thing is I know several of you are from the air quality community in this and familiar with the science and research aspect of the data. So all of the data, as Brandon mentioned, are available in public domain for anyone to download. Um, and if you have ideas, if you want to do some research analysis and publish, we will be happy to help, and feel free to do that. And we can always, me, Prakash, Sagnik, anyone from the team will be very happy to help. If you need more details on the satellite aspect, we can provide that as well. So our idea is to use the data as much as possible for any application you might be able to think of. So feel free to reach to us.
Thanks, Pavan. Dr. Saha has one other question. What's the life expectancy of these sensors? Brandon, do you want to take that question? Brandon?
Yeah, I can take that question. With regards to life expectancy, it's definitely going to be dependent on the type of aerosol or dust that it's, the environment of which it's in, and then the amount of dust that goes through the sensor. Excuse me. From reading the raw sensor manufacturer, it says something like 40,000 hours. So I think that goes into several years. So it has a long life expectancy, but it does need to be watched in case, depending on where it's installed, and if there is some type of, sometimes there's plant or pollen that can get stuck in it depending on the location. So there are some cleaning techniques that can be used if you do find that the performance has degraded over time. And the simplest thing is to kind of put a shop vac or canned air to the bottom of the sensor and try to pull out any dust that's been lodged inside or blow it through.
Thank you, Brandon. While we are on that question, I had a question for you, Brandon, perhaps to kind of clarify. You mentioned about sensor A and B in your presentation. And can you maybe just add a little bit more on what you mean by that? I don't know if it was, I may have missed it, but I don't know if it came across, if everyone understood that.
Yeah, Prakash. So each single raw or sensor node, each purple air device has 2 raw sensors inside of it. And the reason for that is it's taking duplicate measurements. So they're identical sensors and they're obtaining identical data streams. And so by having those 2 raw sensors, if those 2 agree with one another, the scientist can be more confident of the data that has been collected. And also, if there is something that was to happen to one of the sensors, we would still have the A or the B channel that would still be operating correctly. And that allows us to identify whether something has been lodged in the sensor or if there is a spider that crawled in. And we can then determine whether or not we need to perform maintenance on that device.
Thank you, Brandon. So there's one more question. If we encounter a problem with the device, who do we contact? So please reach out to, so we will, when we send a sensor, we'll send you information on the contact information for technical support. So for immediate technical support, please reach out to the IIT Delhi group. I think most likely Dr. Palak will be the point of contact from IIT Delhi. In addition, there is the project team support is, so there's an email address. It's air quality cs@rti.org, and that information will be there in the sensor installation guide. So you can send us an email through that email address as well. Okay, I think let's see here. So I want to kind of share the results of the poll. So looks like we have for how do you check air quality in your neighborhood, nearly slightly more than 50% of the people use mobile apps. About 38% look at the data from the nearby monitoring station. So this is very interesting that almost all of you look at air quality and kind of shows the concern, the interest in looking at the air quality data. And so adding this sensor to, and as an additional tool will definitely, hopefully will be useful to look at the data in your neighborhood. The next question was, how frequently do you check air quality in the region? So that's somewhat evenly distributed. About 1/3 say you check air quality on a daily basis. About 20%, 25% is once a week. And another 38% is during peak pollution season, like Diwali and winter season when the concentrations are high. So again, that kind of tells the level of interest in this, and hopefully these sensors will help provide additional perspective to that. While we are on the sensor topic, there was also wanted to also mention about the AQI, the Air Quality Index. Brandon showed the Air Quality Index on the Purple Air website, so that kind of gives an option. Couple of things to remember. The mapping of the concentration to the air quality index, it's different for India versus what's shown on the Purple Air map. So that was one aspect to remember. So if it's the AQI that you would see on the Purple Air website, it's based on the mapping for based on US definitions. And the second point that we want to mention is, so there's a blog on our website that kind of talks about what that citizen scientist found. And this example was also there in Carmen's presentation. So maybe let me share my screen here. So you can see the website here, the project website. And anyway, so there's this the blog posted on July 9th that talks about the air quality index and how it was different between different data sets. And so that might be a good thing for you to read to kind of help understand about the air quality index itself. But I think the key point that I want to convey is that the definition of an air quality index obviously varies by country, like I just mentioned, but also the time frame. And so the website, if you're going to look at the Purple Air website, I think that's based on an instantaneous concentration, while the AQI that's based on regulatory definitions, either in the US or in India, it's based on whatever the regulatory standard is. It's a 24-hour average. So I think that's another thing to remember is there's a communication aspect that goes along with these sensors, and that is important to remember and keep that in mind when you start comparing the data between the sensor and the regulatory monitors. I think so those were kind of additional points that I wanted to mention, but with that, let me kind of stop there and see if there are any additional questions that you have. If not, then maybe we can adjourn. Okay, so Looks like, anyway, so it looks like there's no more questions, but if you do have additional questions, please feel free to email it to us and we can respond to you. Can send our responses. Like Carmen mentioned, we'll be sending the slides and we may most likely be also posting this on YouTube. There's a project YouTube website so that you can refer to it later. And I think that's thank you everyone. It's 20 minutes beyond the time schedule, but it was important to kind of go through the questions and respond to those. Thank you all for participating. Thanks for your interest in this project, and we look forward to being in touch with you. And thanks to all the presenters as well. I think